Welcome back. So what we're going to do now is we're going to change up our notation. So change of notation. And this change of notation is going to allow us to do a number of really interesting things. So let's go back and let's draw our Cartesian plane again. Let's put on a random curve. This time, let's indicate a point on that curve as x1, but let's use grade 11 function notation now. So instead of calling this y2, let's call this f of x1. So it is whatever this function is. When I pick up whatever this value is, plug it into this function, this is the resulting evaluative number. So there's your domain, there's your range value. And then let's pick up another point that's farther down the x-axis, and let's call that x sub 2. And that, of course, will give us a different range value. And our new range value is now f of x sub 2. And that gives us our 2 points, B and A. Now B will be the coordinates x2 comma f of x2, so no longer y2, but f of x2. And A will be x1 comma f of x1. And if we connect those 2 points, then we will be creating a secant. A secant is a line that connects 2 points on a curve. So this again is the secant AB. And if I wanted to determine the slope of the secant AB, then we would be thinking about rise over run again. And remember, we would be looking at the difference between these two values, and we would be thinking about the difference between these two values. So delta y over delta x would now become f of x2 minus f of x1 over top of x2 minus x1. And that would be a grade 11 interpretation of y2 minus y1 over x2 minus x1. Again, not a lot happened there, but notation changed. So I want to do a change in notation one more time, and we'll put it right below so that you can sort of see the two of them as we work through them. So here's my axis again. Here's a random curve. We will call that random curve f of x. We will put in a value of x. Now, not even x1 this time, just x. And then I'm going to allow my other point to be farther down this x-axis. And how far down? Well, we'll make that h. So this distance in here is going to be h. This vertical distance here then would be f of x. Make my x a little bit more predominant there. And this vertical distance would be f of x plus h. So that's going to give me this point B. That would be represented by x plus h and f of x plus h. And this one down here, that would be A, and it'll be x comma f of x. Creating the two will give you a secant, of course, the same secant that we've been working on. So now the slope of this secant is going to be given by delta y over delta x. So it's the difference between these two. So that's going to be f of x plus h minus f of x. And lastly, it's going to be the difference between these two, which is going to be x plus h minus x. We can simplify that a little bit because we know that if I have an x plus h minus an x, then I'm simply going to be left with the h. This x and this minus x will do away with each other, if you will, leaving us with f of x plus h minus f of x over h. Now, that is the slope of the secant. And so we have 1, 2, 3 different ways to sort of look at this. The interesting thing that I want you to take note of is that in the first one that we did, so looking back to our first example, for me to be able to do any work with this, I needed to know, where's the one where I did some work with it? Here it is. I needed to know 4 pieces of information. I needed to know the x and the y value for A, and I needed to know the x and the y value for B. And so when I'm talking about y2 minus y1 over x2 minus x1, each one of those is a separate piece of information. So there's 4 pieces of information required. Well, this one's a little bit different. If I know what the function f of x is, then I don't really need to know these values. They can be calculated once I know my x1 and my x2. So in this sense, once I know my f of x, I only need 2 pieces of information to be able to calculate the same slope or equation of the secant that I did having 4 pieces of information. And this one becomes interesting as well, because if I know what f of x is, well, then I only really need to know x and h. And again, that's down to just 3 pieces of information, albeit this is a parametric piece of information that we're going to be using. That h is going to be a parameter for telling us where x moves down to my next value along the x-axis. And that's going to have implications when we do some limits and some further work with this. So, where does that leave us? That leaves us with discussing something else about the slope of a secant. The slope of a secant is also called the average rate of change, and that's important. So, average rate of change of a function. So what that's talking about is that if I have a function and I want to know its average rate of change between 2 points. Now, when we say average, you have to remember that we're talking about 2 points. This is going to be the average between 2 points. So we're going to pick 2 points on this curve. We'll call it A and B. And we're going to want to determine the average rate of change between those 2 points. Well, guess what that is, guys? That's slope. The average rate of change between A and B is going to be defined as average rate of change is defined as the slope of the secant. So in this case, the average, now we're going to shorten form this, we're going to average rate of change. So AROC is going to be the acronym I'm going to use from now on. AROC, average rate of change, is going to be the slope of the secant between A and B. Now that's the average rate of change between A and B. If I do it between other 2 points, then it's going to be the slope between those other 2 points. So average rate of change is the slope of the secant between A and B, which is going to be given by a number of different formulas, depending how we've worked with this. It could be delta y over delta x. It could be y2 minus y1 over x2 minus x1. It could be f of x 2 minus f of x1 over x2 minus x1, or it can be f of x plus h minus f of x over h. Now that's quite a different way to represent the same thing. We have a special name for this one. This one is called the difference quotient. Now, the word quotient means the answer to a division question. So there's your quotient. We've got a top, we've got a bottom. If we want to sound smart, we got a numerator, we got a denominator. And it's the difference quotient because it's the difference, delta y over delta x. It's the quotient of the differences between y2 minus y1 over x2 minus x1. So I wrote this upside down, but that's okay. So it's the differences, these are the differences, and it's the quotient of those differences. And this is called the difference quotient. And we need to memorize that. We need to know that inside and out.